Hello mathematicians, and welcome to the 4.2 day 1 video. We are going to be splitting these notes into 2 days. Today we're going to be covering page 1, 2, 3, and part of 4. We're going about halfway through. This is going to be a long video, so prepare yourself, take breaks if you need it, or feel free to watch this at double time. So let's get started. So first we're going to start with some story problems. Temperatures dealing with Fahrenheit versus Celsius. So we can see here that Fahrenheit, or G of C, there we are, Fahrenheit or G of C is 9/5 C plus 32. So first we're going to find and interpret G of 100. So if I plug 100 into this equation, I get 9/5 times 100 plus 32. 9/5 times 100 is 180 plus 32, or 212. So since we know that G of 100 is equal to 212, when we plug in C, or 100 degrees Celsius, we get out 212 degrees F, or Fahrenheit. So we can say that 100 degrees Celsius is the same as 212 degrees Fahrenheit. Now, I'm writing a sentence because it says interpret, but also because this is a story problem. So whenever we're dealing with a story problem, we're going to want to put our answers into context. And we're going to do the same for part B, but instead of giving us C, now it's giving us what it's equal to, or that F value. So we know that G of C is equal to F, so we're just going to set the equation equal to 32 plus 32. We'll subtract 32 on both sides and get 0 is equal to 9/5 C. And then from here, whether we multiply by 5/9 or multiply by 5 and then divide by 9, you're still going to get 0. So 0 is equal to C. So we know that G of C is equal to 32 when C is equal to 0. So that's just kind of me laying out the information that we have. But if we were to put that into a contextualized sentence, we could say that 0 degrees Celsius is the same as 32 degrees Fahrenheit. So we know that Celsius and Fahrenheit relate to each other, but what if I want to solve for Fahrenheit, or what if I want to solve for Celsius? So that's what part C is about. So it says solve the equation F of 9/5 C plus 32 for C, which means now let's try and get C by itself. So I'm going to do that by subtracting 32 on both sides. And then from here, you can either do this in 2 steps, or one, you can multiply both sides by 5 and then divide both sides by 9, or you can multiply both sides by 5/9. Get 5 minus 32 is equal to C. So we've solved to get C by itself. It doesn't ask us to interpret, so I'm not going to write a sentence about this. But now we have C is equal to something. Or essentially what we've done is we have found the inverse of this equation. We've gone the other way, the opposite way, the reverse way. So I always think about inverse as what other words can we think of for that. So down here we have a lot of texts. Feel free to read through this. Something it talks about is a one-to-one function. There we are. One-to-one function is when every y value in the range, there's exactly one x value in the domain. So it's the exact opposite of what the definition of a function is. A function must be one-to-one in order to have an inverse. And I'm going to add on to that that is a function. So we can find inverses for anything, but it's truly one-to-one if the function's inverse is also a function. Today we're just going to be looking at that algebraically. The next video is really going to be focusing on that graphically. Now just a few things to know before we move on. The notation for inverse is right here. That's F inverse of x, so I just want to put that in there so we know how to properly talk about this. That means F inverse of x, that's what you're going to see. Also, that little -1 symbol, that is not an exponent. So I'm going to circle this down here like several times just to say these are not the same thing. That -1 is not an exponent, that's a notational piece. So this is f inverse of x. This is not f to the power of -1 times x. That is something completely different. So now that we know that we're going to be dealing with inverses, let's actually spend some time trying to find inverses and talk about how to do that algebraically. We're going to move to the next page. We're just going to full skip example 2. Don't worry about it. We're going to do part of example 3 right now. We're only going to do part of it because some of it asks for graphing, and we're going to leave that to the next video. So right now, I'm just going to give you the 4 steps that you need to find an inverse. There's a few different ways to do this, but I'm going to stick to this method for now, just because things do get a little complicated later on. So to find f inverse of x, how do we find an inverse? So step 1, this is more of just a notational piece. Replace f of x with y. Now, this is not something that you necessarily have to do, but it just makes it a little bit easier when you're solving. So let's see, we have f of x is equal to 3x plus 2. So first step, I'm going to replace the f of x with y. Okay. Second step, switch y and x. So I'm going to take my y and my x. I'm going to switch them. It's going to leave me with x is equal to 3y plus 2. Now step 3, solve for y. And I'm doing this, now that I've switched y and x, if I solve to get y by itself, I'm essentially undoing all of the steps that we would normally do or finding the inverse. So first thing I'm going to do is I'm going to subtract 2 on both sides. So x minus 2 is equal to 3y. And then in order to get y by itself, I'm going to divide both sides by 3. Now, because I know I'm going to have to graph this later, I'm not going to leave this as x minus 2 over 3, just because that doesn't make sense when graphing. So I'm going to write this as 1/3 x, or x divided by 3, minus 2 over 3. And I'm going to do this because this makes sense in our y equals mx plus b format. But we're not quite done yet because we don't want to leave this as y. So our fourth step is just to undo the first step, which is replace y with f inverse of x. So we can officially say that f inverse of x is equal to 1/3 x minus 2/3 y. So steps 1, 2, and 4 are mostly just notational things. Step 3 is where the real meat of the problem is it's solving. So we're practicing those algebra skills, which is something I feel like we need to practice. So we're going to leave the rest of this problem with the graphing for our next video. So I say let's move on to problem number 3 to just, page number 3, to just go through and find some inverses. So let's move on. Now we're going to find some inverses, but we're also going to verify that things are inverses through composition. So we're taking 4.1, what we have been working on, and bringing it into this new material. Isn't it beautiful how it all connects? So to verify that two functions are inverses, we show that f of f inverse of x is equal to x, and that f inverse of f of x is equal to x. So basically, I'm going to plug an inverse into the other and solve for it. So this is actually asking us to use the previous problem, so we already have those. So remember, if you're thinking about your composition notation, this could also mean f of f inverse, of x, or f inverse of f of x. So we're trying to see those are equal to x. Now we know that f of x is equal to 3x plus 2, and that f inverse of x is equal to 1/3 x minus 2/3. Again, these are from the previous problem that we just worked on. So in order to prove these are inverses, let's first find f of f inverse of x. So this will be 3 times 1/3 x minus 2/3 plus 2. Where's my yellow? So we're taking this f inverse of x and we're plugging it into our equation. But now we need to solve. So first thing I'm going to do is I'm going to take this 3 and distribute it here. So I have 3 times 1/3, or just 1x, and then 3 times negative 2/3 is just negative 2, or minus 2, plus 2. Negative 2 plus 2 goes away. We're just left with x. Yay! But we're not done yet, because we also have to show the other side. So let's do this. So let's do f inverse of f of x. I'm going to move this over just a little bit, so that we have 1/3 times 3x plus 2 minus 2/3. And again, we are taking our f of x and we are plugging it into our equation. Let's see, if I distribute this 1/3, I get 1/3 times 3 is just 1, so that becomes x. 1/3 times 2 becomes 2/3. When we're subtracting 2/3, 2/3 minus 2/3, that goes away, and we're just left with x. Yay! So we have actually shown here, we have proven that these are inverses of each other, because when we compose them, we get x. It's like they're undoing each other. So you can think of this as, if I give you 3x, how do you undo that? Oh, well, you divide. What's the opposite of subtracting? Adding. What's the opposite of squaring? Square root. These are all inverse operations of each other. We're undoing those. So we're undoing all the processes to get x by itself. So that's our goal. But here's the thing. We have to show this, but there's no point in being smart if you can't brag about how smart you are. So we're going to want a conclusion sentence. Something like, since f inverse of x equals x, and f inverse of f of x is equal to x, f of x and f inverse of x are inverses of each other. So we need a sentence there. So if I ask you to prove that two functions are inverses of each other, I want you to show me through composition in both directions. Now you might be like, Ms. Wayne, we literally just found the inverse, so why do we have to do this? Yes, this is for practice. I may eventually give you two functions that are not inverses of each other, and I need you to prove that to me. Now if it ends up being equal to something other than just x, they're not inverses. If I give you two functions and we can simplify them down to just be x, then they are. So that's kind of our practice. This is practice just for now. Okay, we're zooming through this. Good, because the next one's the hefty one. Let's move on to example number 5. It's absolutely beautiful. So let's see, we have the function of f defined by f of x is equal to negative 2x over x minus 1 is 1-to-1. So they're telling us the inverse is a function. Find the inverse function, and then confirm that the inverse function you found is correct by showing f of f inverse of x is equal to x and f inverse of f of x is equal to x. Now, we're going to find the inverse function, and then we are going to find f of f inverse of x. Your first problem in the Go formative is going to be finding f inverse of f of x. So you know it should be equal to x. You're already going to have your answer. The practice is just with the algebra. So we're going to do this first part and the second part. It's going to be your job to find the third. So let's get started. I am going to zoom in a bit just because, I'm still on, there we go. I am going to zoom in a bit just because I know this is going to take up a lot of space. Just as a teacher, these are the things I know. So either write small or maybe grab an extra sheet of paper. Let's get started. So we're going to start with f of x is equal to negative 2x over x minus 1. We need to find the inverse. There's 4 steps. Step number 1, replace f of x with y. So y is equal to negative 2x over x minus 1. Step number 2, switch your x and y. Now, there's more than one x here, so we're going to replace all of those x's with y's. So this becomes x is equal to negative 2y over y minus 1. So we've replaced all the x's with y's. Third step, solve to get y by itself. This is where it gets fun. So I take a look at this and I go, okay, can't divide anything here. In order to get rid of a fraction, no matter what, I'm going to multiply both sides by the denominator. So I'm going to multiply this by my y minus 1. I'm going to multiply over here by y minus 1. So we end up with x times y minus 1 is equal to negative 2y. Okay, so I'm here. I got to start moving things around. I can't just divide again, so we're going to distribute this x. There we go. So we get x times y minus, not 1, minus x. There we go, minus x is equal to negative 2y. And then from here, I'm going to start moving things around so I can get y on one side of the equal sign and everything else to the other side. I don't really care about the x's for right now because I'm trying to get y by itself. So I'm going to add x to both sides. So I get xy is equal to positive x minus 2y. And then I'm going to add 2y to both sides so I can get all my y's on one side. So xy plus 2y is equal to x. Okay, so I've rearranged things to the best of my ability so that all the y's are on one side of the equal sign. Feel free to rewatch that first part in case we're a little confused. But we get to here, this is the number one place. I'm going to star this right now because this is the number one place where everyone always gets stuck. There we go. It's where everyone gets stuck. So I'm going to do some practice work off to the side with something that we might be more familiar with just so that we feel more comfortable. So if we have 2x minus 8, and I asked you to maybe simplify this or divide something out, you might say 2 times x minus 4. You found something that was in common with both 2x and the negative 8, and you pulled that out, or you divided that out. So you divided out of 2. We're going to be doing the exact same thing right here. I noticed that the xy and the 2y have a y in common. So I'm going to factor out, there we go. I'm going to factor out the y, or divide that out. Oh, I forgot we are still in green. Let's fix that. There we go. So we're going to change that into y, and xy divided by y gives us x, and 2y divided by y gives us a positive 2. Now, the reason that we can do that is we're just left with one y. This whole time we've had 2 y's, and that doesn't work for us. So we found a way to bring us just one y. And now we're going to divide both sides by x plus 2. And we get y is equal to x over x plus 2. And we figured it out. Yay! But we're not done yet. Remember, our very last step is to change the notation. So we're going to replace y with f inverse of x. If you like, we can go over this again when we meet each other on Monday for the Go Formative. Just please let me know, and I can go over this again or similar problems like this. But remember, this was just part 1 of the problem. Now we need to prove that f of x and f inverse of x are inverses. So now we need to compose them. I'm going to do one of the compositions. I'm going to have you do the other. So we right now are going to find f of f inverse of x. So f of f inverse of x, and I'll move this all the way over in just a moment, is going to be, let's see, negative 2, and then instead of x, it's going to be x over x plus 2, divided by, instead of x, it'll be x over x plus 2 minus 1. So, I'm missing a parenthesis here. I can see that we have our f inverse of x, and I've put that in for wherever we see an x. So let's simplify this, shall we? Look at all of those beautiful fractions. Let's see, for my numerator, first thing I'm going to do is I'm going to distribute the negative 2. Now, I'm not going to distribute the negative 2 to both parts of the fraction here. I'm only going to distribute it to the x, because remember, you can think of this negative 2 like a negative 2 over 1, because we can take any constant, put it over a 1, and we're just multiplying straight across. So this becomes negative 2x over x plus 2. Okay, so that's our numerator. We simplified that. And now we need to simplify the denominator. And we've come across this issue before whenever we have a plus or minus something with a fraction. We're going to change this minus 1 into a minus 1 over 1 and then find a common denominator, which in this case is going to be x plus 2, top and bottom. So this is going to be in our denominator x over x plus 2 minus x plus 2 over x plus 2. Now, when we officially subtract these fractions, I want you to watch what I'm doing here. So negative 2x over x plus 2, I didn't change the numerator at all, divided by x minus parenthesis x plus 2 over x plus 2. Now, the reason I use that parenthesis is because so many of us are going to just do minus x and then leave the plus 2 there. Do not do that. We're going to need to distribute that negative. And one of the reasons is that's so important is that we know that these are supposed to be inverses of each other, so we're supposed to come out with just x at the end. We know what our answer is supposed to be. So if we make an algebraic mistake somewhere, that's most likely where it's going to be. But that would bring us to an answer not just x. That would tell us to go back. But anyway, let's take that negative and distribute it. Doop-a-doop. So that's going to bring us negative 2x over x plus 2 divided by x minus 2 over x plus 2, or negative 2x over x plus 2 divided by negative 2 over x plus 2. Now, we've dealt with this before. We know there's a few different ways to deal with this. I'm going to take this out to the side and rewrite it the long ways, because that helps me. It's going to be negative 2x over x plus 2 divided by negative 2x over x plus 2. And we'll multiply by the reciprocal. So that'll be negative 2x over x plus 2 times x plus 2 over negative 2. Now, there's a few different ways you can cancel here. I'm going to start by canceling out the x plus 2 on top and bottom. So that's going to bring us back to negative 2x over negative 2. And you may have already canceled this out earlier, but negative 2 over negative 2 goes away, and we are just left with x. Look, we know we did it correctly because it told us we were supposed to get x. So, like I said, this problem was a little long. I'm going to zoom out. Look at all that work. So we went through and we found the inverse right here. Here, next step we did was proving they were inverses through composition, but you have to show both methods. So now it's up to you to find f inverse of f of x. Please let me know if you have any questions. I look forward to seeing you on Monday.